Okay, number one, simplify the expression. So what we're going to want to do is, in order to use our exponential rules, we're going to need to have the same base. So we can get 27 to a base 3. So we're going to have 3 to the 1/4 times 27 is the same as 3 cubed to the 1/4. So 3 to the 1/4 stays. 3 cubed to the 1/4 is 3 to the 3 times 1/4, which is 3 to the 3/4. And that is 3 to the 1/4 plus 3/4, which is 4/4. And 4/4 is 1, and 3 to the 1 is 3. And that's it. Remember your rules. If you have an exponent raised to an exponent, you multiply the exponents. If you're multiplying with the same base, you add the exponents. Write in radical form, x to the 1.5. Well, 1.5 is 3/2. It's 1 1/2. So if I'm going to rewrite that, it's going to be the square root of x cubed. Write the expression in exponential form. So c, the fourth root of c squared is going to be c to the 2/4 power, and 2/4 is 1/2. That's an easy one. Find the quotient. So for these, what you want to do is put them in exponential form first. So we're going to have 4 to the 1/6 power divided by 4 to the 1/3 power. And when you divide with the same base, you're going to subtract the exponent. So 4 to the 1/6 minus 1/3, which is 4 to the 1/6 minus 2/6. I cannot stand that word. So that's going to be negative 1/6. And that's it right there. I mean, another way you could write it is the 6th root of 1/4, because it's the 6th root of 4 to the negative 1, and 4 to the negative 1 is 1/4. Either way, I would accept that. Alright, so we have an exponent raised to an exponent in both the numerator and denominator. So we're going to have x. Negative 2/3 times 15 is going to be negative 10, because 3 goes into 15, 5, and 5 times negative 2 is negative 10. And in the denominator we have y. Negative 1/3 times 15 is negative 5. Now we want to write this in a form where the bases have positive exponents. So if we can do a switcheroo, we would have y to the 5th over x to the 10. Number 6, we're going to have 5 to the 2 root 3 times. Let's make this 25 a base 5, so 5 squared to the negative root 3. So we have 5 to the 2 root 3 times 5. 2 times negative root 3 is negative 2 root 3. Whenever you multiply with the same base, you keep the base, you add the exponents. A 2 root 3 plus a negative 2 root 3 is 0. Anything, well, 5 to the 0 would be 1. That's it. Number 7, 2 root 12 minus 4 root 27. So this is a review problem where we're going to break down the radicals. So we have 2 times the square root of 4 root 3. 2 times the square root of 4 times 3 minus 4 times the square root of 9 times 3. You want to break up the inside of the radical to get the largest perfect square. So this is 2. The square root of 4 is 2. 2 times 2 is 4. So you have 4 root 3 minus The square root of 9 is 3. 3 times the 4 on the outside is 12 root 3. So 4 root 3 minus 12 root 3 is negative 8 root 3. Factor completely. Well, for this one, this is a perfect square, it's 5x. That's a perfect square, it's 4y. Let's see if it's a perfect squared trinomial. If we take these and multiply them, you get 20xy, and if I double it, I get the middle term. So it is a perfect squared trinomial. So it's going to be 5x, you take the middle sign, and then 4y, and then it's squared. Number 9, what is the y-intercept? So here's your function. The general rule is whenever you want to get the y-intercept, you set x equal to 0 and you solve. So if I set x to 0 here, I'm going to have f of 0 is 4 times the absolute value of 0 minus 2 minus 5. So f of 0 is 4 times 0 minus 2 is negative 2. So f of 0 is 4 times the absolute value of 2 is 4 times 2, which is 8. 8 minus 5 is 3. So the y-intercept is 3. And number 10, what's the mistake here? So the original problem is this. We have a binomial divided by a binomial, and the denominator has a radical in it. So we want to multiply by the conjugate. That's what you would do. So that's what they did here. They multiplied the top and bottom by 3 plus root 2. So that's correct. Let's see if they multiplied correct. The denominator, you only have to do f and l since they're conjugates. So 3 squared minus root 2 squared. That's correct, because this is 9 minus 2, because root 2 squared is 2. The denominator is correct. For the numerator, they would have to FOIL that out. Doesn't look like they did that. They should have done 3 times 3, 3 times root 2 times 3, root 2 times root 2. They only did the f and l in the numerator where they should have done FOIL. So you would just explain that FOIL wasn't used. Only f and l was used. And obviously you want to use complete sentences and all that. I don't want to have to write out a whole paragraph here. Just explain that FOIL was not used. They only did the f and l and FOIL in the numerator. And the reason why they should have used FOIL is because 3 plus root 2 and 3 plus root 2 are not conjugates, and they're binomials. And that concludes the worksheet for 6-4C.